Alright, so I'm going to explain here using this sales data how to get the average and the variance. So with average I'm meaning expected value, and the variance using a kind of long form that relies on probability. So I've got a set of data here, and the first thing I'm going to do is I'm going to create a pivot table with those data. So insert pivot table, click OK, and it brings this up for me here. So then I've got the sales values, and I put those in the rows, and as you can see here there are possible different sales values, sales of 1, 2, 3, 4, 5, 6, or 7. These would be units. And I bring the sales value also down into the area here, the sum of values. And I need to make a few changes here because this is adding up the values here. So for example, with 7, there were not 14 different instances of 7 sales. There were 2 instances of 7. 2 times 7 is where that 14 is coming from. So I need to do a few things here. So I'm trying to get at something like a probability. So to make that switch, I'm going to change this to count. So show me how many of those happened. And then I want it as essentially a relative frequency. So I want to show the value as a percent of the grand total. That will give me something that essentially is a relative frequency, which I can then interpret as a probability. So now I'm going to take these values, since they're expressed as percentages, and I want to express them as not percent frequency, but relative frequency, so that they'll mirror probabilities, values between 0 and 1. So I'm going to format the cells, and I'm going to switch this to number, and click OK, so that the percentages have now been switched to something that bears a greater resemblance to a probability. Alright, so I'm going to now copy these out of the pivot table, because the pivot table will sometimes create some little, I'll call it wonkiness in what's going to go on. So the first step here is I want to label these things. This is my x value in this column. Then in the b column, this would be the f of x. Right, oops, or something like the probability. We took it from, though, the relative frequency. That's where I got it. So here I want x times f of x. So I'm just taking what's in column A and multiplying it by what's in column B. And I copy that for all of them, so I do that for each of these. Get that there. Now, the sum is going to be the expected value. So I'm going to just get the sum of these values, take that there, I add them all up, and I get 3.4. Now, I want to do something just to double check that I got the right value in this occasion. So I'm going to go back to the first sheet, and I'm going to just ask, what is the average? I think it should be 3.4 if it matches that value below, so, or that value that I just got. So I'm just going to scroll down here, grab all the values in there, and it shows an average of 3.4. So that's good news, that matches here. So now I want to do a couple of things to get the variance. I'm going to need to find the difference between the value and the mean. So just call that difference. So what is that? It's the value, so in this case 1, or whatever's in column A, that cell, minus 3.4. I want that same thing copied into each cell here. So for the values 2, 3, 4, 5, 6, and 7 to get those. So then I need to take the difference and square it. square those values. So I'm just taking the value in this column, column D, and squaring it. Do that for each of them. So I'm going to copy this into all the other cells, get those. And then I need to weight those. So over here, what I'm going to have is I'm going to have the weight f of x times these squared values, right? X minus e of x. And those things are all going to be squared. And that looks like I need a parentheses closure there. So I get these values by doing what? I take the f of x, this value here, times this squared difference, this value here. I need to copy that across all the cells. Do that there. And then down here, I'm going to say that the sum is the variance. So I need to add those values up. And I get a variance of 2.44. Let's check if that matches. So go back here. And I'm going to type in VAR. And this time I'm going to do something that maybe is a little unusual. VAR.P. So this is the population variance. So the formula that I've just used to get the value for the variance using that long table approach is the population variance, which is typically not what we want. We typically want the sample variance, but that's what this is giving us, so let's just check it this way. R.P, need to copy in all the values, and whoops, it'll stay. And sure enough, it's 2.44, so that worked. So hopefully those steps will help you get through this kind of problem. Of course, as you can see, it's often just a lot easier to use functions like average or VAR, and that long table formula is often not necessary, but it does show you the steps or how this would play out in this scenario. Thank you.